So 4.1 and 4.2, we're going to talk about the non-polynomial functions. Okay, so the 4.1. Okay, so give me a second. What does that mean, non-polynomial? So the the so we can classify the type of functions in two groups: the algebraic functions. So, oops. So see, algebraic functions. Okay, let's say function, and the second one is a transcendental functions. The function. Okay. So what does it mean, algebraic functions? Yeah, algebraic functions include the polynomial functions, and then power functions, root functions, and then the rational functions. Okay, the rational functions means the having rational function have the form fraction and then numerator denominators polynomial. Okay, so all of the and then all of the other functions, then those functions, polynomial or power or root rational functions are called transcendental functions. For example, exponential function, logarithmic functions, that's what we're going to study in 4.4.2. And then the sine function, cosine, trigonometric functions, maybe you may heard that, but that's the out of subject, so I'm not going to cover that one. So see, so we're going to focus on transcendental functions. Okay, so 4.1, we're going to talk about one of them, one of the transcendental functions, the exponential functions. Okay. So here objective. So yeah, definitely we need to learn the definition of functions, exponential functions. Okay, let's just say exp. Okay, and then we're gonna learn the graph. Okay, graph of exponential functions. Okay, and then while just we figure out the graph of exponential functions, we're gonna figure out the property of exponential functions. Okay, and then we figure out how to find the root of exponential functions. Then we need to let me think how to find root. Okay, so then we need to figure out we need to study one-to-one property. Okay, and the last one is we're going to study compound interest. Okay, so now what we're going to do is the compound interest is the application of the exponential functions. This is really applicable kind of. Okay, so this is really useful to figure out when you deal with some car loan or mortgage loan, something like this. Okay, so now these definitions. Okay, first one is f of x is the exponential function defined by a to the x. Okay, so you see that x is in the exponent, right? So a is called the base. So this a is called base. Then x is called the exponent, right? And then now you see that exponent is a variable x, right? And then one thing you should keep in mind is a must be greater than 0, and a should not be a 1. Okay, so keep in mind this is really important. Okay, so because of that, because of that restriction, we can think about two cases. The case one is a is between 0 and 1. Okay, and then case two a is greater than 1. Okay, so let's figure out the graph of exponential function for each case. Okay, if a is greater than 0 and 1, then for example, let's say a is of just 1/2. Okay, so now then graph of the exponential function when a is 1/2 is this, like this. That makes sense. Why? Because think about this. F of x is defined by 1/2 to the x power. Okay. If x is negative 2, we're gonna get what? 4. If x is negative 1, we're gonna get 2. If x equals 0, then we're gonna get 1. Okay, so this is gonna be 0, 1. And then when x is 1, then we're gonna get 1/2, and then x is 2, we're gonna get 1/4. So as you can see that as x is increased, the y value is decreasing, right? Makes sense? Because you see that base is the less than 1. So the exponent is increasing, then that exponential expression will be getting, smaller and smaller. So we see that when the base is between 0 and 1, then the graph of the exponential function is like this, decreasing, right? So not only a is 1/2, because there's any base between 0 and 1, their graph must be like this. Okay, so then what about the other case? So example, a is 2. So they want to figure out the graph of the 2 to the x power. Then this is a totally opposite than this. As x is increased, then y is increasing, right? Does it make sense, right? So graph must be like this. Okay. So now then, see here, the y-intercept must be 0, 1. Why? Because when x equals 0, then 2 to the 0's power is 1, right? So here we can figure out that what? For any choice of base, if exponent, x value is 0, then the output, y value must be 1. So 0, 1 must be y-intercept for any choice of a. Okay, either case 1, case 2, for any choice of a, definitely that number satisfies that condition. Okay, so for any choice a, their y-intercept must be 0, 1. Okay, keep in mind this. So the other one is this: either graph never touch x-axis. Okay, because think about this. For this case 1, if x is just what x value makes that 1/2 to the x power to be 0. There is no such a x value. Okay, even you plug in x to 100 or 1000, 1/2 to thousands power is just, you can say that number really, close to 0, but that doesn't mean that equals 0. So the graph will never touch x-axis. This is the same, okay? Second case, as x is, maybe we plug in negative 1000 to x, then what? 2 to negative 1000 is just really small, 0.00, something like this. But that doesn't mean that equals 0. So these two graphs never touch x-axis. So here, then, so just figure out the range and the domain, okay? And then we figured out y-intercept already, and then x-intercept, no, I told you, because those two graphs never touch x-axis, so there is no x-intercept. Now then, the domain is what? Domain going to be negative infinity, infinity for both cases, okay? Okay, and the range is 0 to infinity. So 0 is included? No, I told you, because the graph never touch x-axis. It means that 0 cannot be, included in the range. So open interval 0 to infinity, range 0 to infinity. Okay. Then what's the difference between two cases? I told you. This case 1, the function is decreasing, okay, for 90 infinity infinity, and for case 2, the function is increasing from 90 infinity infinity. Keep in mind this. So now we got this, and the property of the exponential functions, right? So next one is before decovering the objective. Let's figure out the let's see examples in textbook. Okay, so give me a second. let me open the online textbook. So example 4 in textbook. So the problem says that sketch the graph of each function. So, but let's say just b. Okay. So f of x is defined by -4 plus 3 to the x plus 2. So to solve the problems, we need to use the transformation, what we learned on chapter 2, 2.3. Okay. So I'm gonna start from the graph of g of x defined by 3 to the x power. Okay. So the graph of the 3 to the x power is should be like that, because see that base is 3, which is greater than 1. So g of x must be increasing function. That's the graph of g of x, and then minus m is 0, 1 right there. Okay. And then now we're gonna apply the Horner translation, and then maybe stretching, shrinking, reflection if it's necessary, and then we apply the vertical translation. Keep in mind that order. So first one, see that x plus 2, that's the, to get x plus 2, we need to apply the ht, for original translation, okay? So replace x by g of x plus 2, okay? That's the shifting the graph of g of x to the left, right? 2 unit, okay? So which is the 3 to the x plus 2, okay? So we move the graph to the left, okay? Okay, 2 unit. So graph must be like this, maybe like that. Okay, so this is g of x plus 2. Okay, and now we apply the same -4. That's the vertical translation, right? So this is going to be g of x plus 2 -4, which is 3 to the x plus 2 minus 4. Okay, so that's exactly the same as what f of x, right? So this is what in the graph, graph of g of x plus 2, we shift down, right? There's 4 units, right? So make it maybe like this. Okay, roughly. Okay, so this is going to be graph of f of x. Okay, so now let's figure out what happened to that point minus a. Once we apply the ht, then the point moved to the left, right? So right here. Okay, that's going to be what, -2, 1, right? 1, and then move down to 4 unit. So we're gonna get the point right here. I know this is kind of weird. Okay, this is the graph. You know, the red, the colored by red should pass that point. This is -2, -3, right? Because move down, shift down 4 unit. Okay. All right. So now, next one is the 1, 2, 3, 4, and the one-to-one property. So what that means, well, think about this. A to the x1 is equal to a to the x2. Okay. So two exponential expression have the same base. Okay. Then if and only if what x1 must be equal to x2. So here x1, x2 represent algebraic expressions. Okay. Could be polynomial. Okay. So this is used. This is called the one-to-one property. Exponential function. So why this is useful? Because the let's see the example. See, yeah, example 7 textbook. So let's think about this. F of x is defined by 5 to the 2 minus x. Okay, so let's say, and the equation is this, find the x, okay, such that, okay, that means st means such that f of x is defined by 125. Okay, So then what? We just to find x such that f of x is 125, then we construct the equation like this: 5 to the 2 minus x is equal to what? 125. Okay. So now then, you can see that 125 on the right hand side can be expressed as exponential function expression: 5 to the third power, 5 times 5 times 5, 125. So this is nothing. 5 to 2 minus x is equal to 5 to the third power. So now you see these two guys have the same base, so that we can use a one-to-one property. It says that if two, in the equation, left hand side, right hand side is has the same base, then what? 2 minus x must be equal to 3. So 2 minus x is equal to 3. So x must be what? -1. Okay. So when you look at when you try to solve that problem directly, it's really what? We don't have any what? We don't know any the method to solve this problem, that one directly, but using the one to property, this kind of complicate, the problems turns out to be what? Just simple linear equation. So yeah, it's easy to figure out, solution of that linear equation, right? So this is why this is one to property is really useful. And then the last one, compound interest. Compound interest is this. Let's see. Mm, Give me a second. Yeah, you see compound interest right there. So what's the compound interest? This one interest give us the what formula for calculating the actual amount after years with a certain rate of the when you deposit principal P. Okay, so if a principal P is invested for T years at an annual rate R, compounded n times per year, then amount A or ending balance is given by this. A is equal to T times 1 plus R of n to the n T. So one thing that you should keep in mind is the n, when you figure out n, you need to keep in mind this. N is a number of times compounded per year. Okay, so keep in mind this. So what that means, give me a second. Let's see. Oh, okay. So let's see example 8. Okay. So find the amount of future value when a principal of 20,000 is invested 6% compounded daily for 3 years. So see that compounded daily, then n must be what? 365, because n is a number of times compounded per year. Because 1 year is 365 days. So n must be 365, okay? And then principal P is a $20,000, and the rate is 6%. Converting to the number, it's going to be 0.06, okay? And the 3 years, it means that T equals 3, because the T is a number of years, okay? So, and then once you figure out all the parameters, P, R, and T, and just putting them into the formula and then using calculator, then you can figure out that, okay? So now then, see, next one is, wait a second. Oh, sorry. So, okay, now is continuous compounding and number E. Okay, so I'm going to talk about this one. Let's see. Mm, Now, let's see that. So think about the this investment. Okay, so let's see. The principal is $10,000. Okay, invest at 12% rate for 1 year for more and more frequently compounding. Okay, so just think about, all right, so balance. Let's figure out the balance for the principal P of $10,000 invest at 12%. Okay, and then with different number of times compounded per year. Okay, then look at the table right here. So if what if that what the number is the compounded annually, that means n must be 1. Okay, so that the amount after 1 year will be just $10,000 times 1 plus 0.12. 0.12 is 12% rate, okay, over n, which is 1, to the n times t, because we want to figure out the amount after 1 year. So t must be 1. Okay, so we got the 1 right here. Okay, and then quarterly going to be what? How many quarter in a year? It's 4, right? And then n must be 4. You see that is 4 right there in the bottom. Okay, and the top one is 4 times, because top one, the exponent must be n times t. So n must be 4 and the t is 1, right? The monthly, that what? N must be 12. And the daily is 365, and the hourly is 8,006. Yeah, the 8,600, 760. Okay, because how can I figure out the hourly? Because 1 day is 24, right? 24 times 365, that's going to be this. And then what about the continuously? Then continuously is, then we'll get this. P is equal to, oh yeah, let me show the, what, the slide. This A times P times E to the RT. So what is E? Okay, so E is a natural number, okay? E is a natural number, is approximately 2.714 something, okay? This is an irrational number, okay? So E is approximately 2.714, okay? So where that comes from, that's beyond of this subject, so I'm not going to cover that one, okay? But you can get kind of clue how we get this one in the textbook. Just look at it, okay? The name of E is called natural number. Okay, natural number, right? So now we'll see. Okay, so let's see example 9 as an example, okay, of the compound interest. Okay, so just keep in mind is two compound is interest, okay, compound interest and then continuous compound interest, okay. So then example 9 is this. Let's show the textbook. Let's see. Yeah, let me just copy this. Okay, problems. So these are problems. Find the amount when a principal of 5,600 is invested. Okay, so P is 5,600. And then rate is 6 and 1/4%. So this is 6.25%, right? So that is a 0.0625, right? And the annual rate compounded continuously. As continuous, so it means that we got to use that formula. P is equal to A times 1, so A times E to D RT, right? Okay, that's the formula for the compound interest. Okay, and then the problem says that yeah, compounded continuously for 5 years 9 months. Okay, so now then 5 years 9 months, then okay, 5 and then 9 months must be what? 9 over 12, right? Because we have to convert the months to year. Okay, 9 months is what? The 9 over 12 year, right? Okay, so 5, and this is approximately not 5.75. 5.75. Okay, so we plug in this number into T, and then we plug in 0.0625 into T, into R, and then we plug in This should be A, right? This should be P, sorry. We plug in principal P into right here. Okay, so now the amount is going to be after invested these parameters is going to be 5, 600, and then e to the 0.0625 times 5.75. Okay. Okay. So keep in mind this. Now then, next one. So we're gonna move to the 4.2. Okay. Give me a second.